Hey guys, welcome back to Scribble Aura. In today's lecture, we'll talk about mesh and nodal analysis and also about supernodes. So let's get started. So basically, a circuit has two sources. One is a voltage source, another one is a current source. If a circuit has an voltage source, then it's better to use mesh analysis, and if a circuit has a current source, then it's better to use nodal analysis. So now we'll talk about mesh analysis by solving some problems. You know what is a mesh, all right? Mesh is a thing which does not mesh is a loop which does not have any other loops inside it. So here in this circuit, if you take for example, there are two meshes. So one is this mesh, another one is this mesh. First, whenever if you see a mesh for mesh analysis to solve it, I want you guys to put a clockwise loop like this, right, and name it as I1 and I2. And why we are putting this loop in a sense, we'll write the values according to the loop, how the loop goes. So for example, for the first mesh, how will you write an equation is, uh, for an voltage, if we are going from negative to positive, if you're going from negative to positive, you have to write minus the value of the voltage. So here, for example, 10. So I'll write minus 10. If you're going from positive to negative, then you will write plus 10. Something happened. Okay, plus 10. All right. So, so first, how will you write for this mesh? The equation is, it's minus 10 plus 5 into I1, that is V is equal to I into R. So 5 into I1 plus for this 2 ohm resistor, there are two currents passing through it. One is an I1 which is coming in the clockwise direction. Another one is an I2 which is going in the opposite direction. So you will write 2 into I1 minus I2 because I2 is going in an opposite direction. So 2 into I1 minus I2. Alright, so first, okay. So it's minus 10 plus 5 I1 plus 2 into I1 minus I2, and you will, if you solve this equation, you will get the first equation like this, like grouping I1 and I2 separately. And if you take the second mesh, okay, if you take the second mesh, your thing will be going like this, right? So it's 2 into I2 minus I1 when you're considering loop 2. If you're taking second mesh, you will write I2 minus I1, whereas if you're taking first mesh, you'll write I1 minus I2. Just be clear in this concept because here is what people confuses. Alright, so it's 2 into I2 minus I1 plus 10 into I2. Here from positive to negative, so it's plus 50. Alright? Yeah. So it's equal to 0. So if you solve this by grouping I1 and I2 together, you will get the second equation. And just solve these two equations in the calculator, you will get I1 and I2. I've written it step by step. You just solve it. Alright, there's one more method to solve this, which is a matrix method, but I'll basically generally use the equation method, but there's another method also which is called as a matrix method. So how to do this matrix method is, so first we'll do, so this is a matrix and this is how you'll write. So in A11, this place you will write sum of all the resistors in mesh 1. So here in mesh 1, 5 and 2 resistors is, so 5 plus 2 is 7. So here you will put 7, right? And here the common resistor between both the meshes, so it is 2. So here 2 will come. And here is also common resistor between both the meshes. So here also 2. Here sum of the resistors in mesh 2, which is 10 plus 2, 12. So this is how you will solve. Into I1, I2 is equal to here 10 and here plus minus 50. I'm sorry. Yeah, minus 50. And I hope you guys know Cramer's rule, which you guys have learnt in 11th or 12th standard. I don't remember. So by Cramer's rule, how will you solve a Cramer's rule? First, you will take determinant of this matrix, and then delta 1 will be your first thing in Cramer's rule. Like you will put this 10 and minus 50 in the first column, and you will solve the determinant, and I1 will be your delta 1 by delta. It's just a basic Cramer's rule, and I think I don't need to explain this much. And similarly I2. All right. Okay. Now we'll move on to the next question, which has, so here you can see that this circuit has 3 meshes, so you'll get 3 equations. If you have 2 mesh, 2 equations, 4 mesh, 4 equations. Alright, just solve these all equations in the calculator. If you don't know how to solve equations in a calculator, just comment below, then I'll put a separate video for how to solve equations in calculator. All right. So now let's move on. Let's move on to the next question. So this is the next question. So here you can clearly see that you have three loops, three meshes. So I said that whenever you are seeing a mesh, you have to just put a thing in a loop in a clockwise. All right. So how will you write this? So it's from negative to positive. So it's minus 50 plus 10 into I1. Here 5 ohm resistance has two currents passing through. One is I1 in this direction and I2 in the opposite direction. All right. So 5 into I1 minus I2 plus 3 into I1 minus I3, because I1 is in this direction and I3 is in this direction. I hope it is clear. Solving this equation, you will get the first equation right here. Next, you are moving on to the next mesh, which is this. So here you will have 5 into I2 minus I1. Yeah, when you are taking this mesh, you have to consider with this. So I2 should be positive here. So here 5 into I2 minus I1 plus 2 into I2. Here it is plus 10 because from positive to negative. Alright. Plus 1 into I2 minus I3, because I2 is going in this clockwise direction and I3 is going in this anti-clockwise direction. Alright. So when you are solving this equation, I hope it is clear. If it is not clear, just comment below. I'll make a separate video for this again. Next, we are taking the third mesh. Third mesh, how will you write it? 3 into I3 minus I1. The similar way, 1 into I3 minus I2 plus 5 is equal to 0. If you solve this, you'll get three equations. Solve these three equations in the calculator. You'll get I1, I2 and I3. This is how. Now we are done with the mesh analysis. So now we will move on to the nodal analysis. So nodal analysis is to find voltage. So whenever in question they are asking us to find voltage, it's better to use nodal analysis. So basically, if you see in this circuit, you have two nodes. First of all, what is a node? Node means when three or more branches meet together, then that forms a node. So here in this circuit, you have two nodes right here, and I want you to put the arrow marks which is going outside the node. All right, so like this, right? Every direction. All right. Similarly for this node also. Right, every direction outside it. So this is nothing but current which is moving outside the nodes. All right, so this is how you'll write the equations also. So how will you write here? If you see the current source is in this direction, and here the current is also coming in this direction, and here the current is moving in this direction. So both are in opposite directions to each other. So here you'll put minus 5. All right, so it's minus 5. All right, then from a node, okay, vi is equal to v by r. Here the current is what is given, so here you will put v1 minus 0 because it's ground. Here also it's 0 only. All right, so v1 minus 0 by 10. Similarly, this node minus this node, the divided by the resistance in between the nodes. This is how it works. So v1 minus 0 by 10 and v1 minus v2 by 3. All right. Now coming on, okay, then solving these things by using LCM or whatever it is, how much ever you solve, you'll get this equation. All right. When you're taking the second node here, similarly you will draw all the arrow marks outside the node. So this will be v2 minus this node v1 divided by 3 plus v2 minus 0 by 5 plus v2 minus 10 by 1. All right, solve this, you will get another equation. Solving these two equations in calculator, you will get v1 and v2. Acha, it's very simple. If you see the next question, so here you can see there are three nodes. So what is the node? Three or more branches meet together at a point. That point is called as a node. All right, so here there are three branches right here. It meets together. This is a node, and this is also a node. This is another node. So here there are three nodes, meaning you'll get three equations. If you have two nodes, you'll get two equations. So now we have to draw the arrow marks outside each node. All right, so like this. So first, how will you write for V1? So V1 minus 20 by, see this voltage minus whatever voltage is there in the opposite node divided by the resistance in between. So this is how it works. So V1 minus 20 by 3. Here V1 minus V2 by 1. V1 minus V3 by 2. Right? Solve this using LCM. You will get this equation. Next, for V2, you will draw all the nodes outside. All the currents moving outside. So here it will be minus 5 because the current 5 ampere is moving in this direction and this current is coming in this opposite direction. So you will write it as minus 5. Alright. Plus V2 minus V3 by 6. V2 minus V1 by 1. Alright. Is equal to 0. Solve it using LCM. You will get next equation. Next is moving on to this node V3. Here you will write V3 minus V1 by 2. V3 minus V2 by 6, V3 minus 0 because it's a ground by 5. If you solve that, you will get one more equation. Solve these three equations in calculator, you will get V1, V2 and V3. Alright. I hope nodal analysis is also clear. Just first of all, mesh analysis, you have to find how much meshes are there, draw loops accordingly and draw equations according to how the loop goes. Right? And solve it. In nodal analysis, you have to put how much nodes are there. You have to calculate that first, and from each node, you have to draw and solve the equation and solve those equations. You'll get the answer. Now, there is a next thing called as a supernode. What is a supernode? Supernode is nothing but if you have an voltage between two nodes. Alright, you see here it is one node, this is another node. See, generally in these questions in nodal analysis, we saw that there was a resistance in between two nodes. But here you can clearly see that there is an voltage between two nodes. So if there is an voltage source between two nodes, then that is a supernode. How to solve it? So here, so there are three nodes right here, and between these two nodes you have an voltage. So these two nodes are the supernodes. Alright, so this V1 is also a node. For this, we can write it generally. So how will you write? This is minus 10 because this is coming in this direction, this is coming in this direction. So it will be minus 10 plus V1 minus 0 by 3, V1 minus V2 by 2. Solve it, you will get this equation as usual. Right? Now, when you are going to this node and this node, what you will do is you will combine these two nodes. Except this part, okay? So except this part, you'll combine all the nodes. So how means, yeah, I'll tell you, just write it out. V2 minus V1 by 2 first. Then V2 minus 0 by 1. This is second thing. You will not write this as it is a supernode, but instead you will join this V3 nodes also with V2. Instead of writing it as three equations, you will combine and write it as two equations. I hope it is kind of clear. So it's like V2 minus V1 by 2, V2 minus 0 by 1 plus V3 minus 0 by 2 plus V3 minus 10 by 5. See here, you will combine everything except this part. Acha, alright. So, yeah, if you solve this, you will get an equation. Next, we didn't touch this, na? You have to write one more equation based on this. Like this minus this is equal to this, right? So, it's by V2 minus V3 is equal to 20. I have written it right here. Right here. Alright, so if you solve these three equations, you will get V1, V2, V3. I hope it is clear how to solve a supernode. When you have an voltage between these two nodes, then that is called as a supernode. And you have to, when you find a supernode, it's very simple. It's just like a normal nodal analysis. It's that you have to combine two nodes or the nodal analysis together and write it out. I hope this question is clear. If you have any doubts, just comment below. And thank you all, guys. So that's all for today. And please do subscribe to get more videos of this BEEE series. So thank you all.